All right, so remember what we were doing last time? We were talking about finding the point of intersection of two lines. So how are we going to code this? We solved this example by hand by setting the two y values equal to each other, finding x, plugging it back in, finding y. Then we did the same thing in general for any slope A, any intercept B for this line, any slope C, any intercept D for this line, and we found x here too. And again, you can find y by plugging that back in. Can we write this code? Are you ready? All right, time to code. Alrighty, so where's my calculating device? Where did it go? Here it is. I don't need this, I don't think. Okay. All right, so we're going to write a program called point of intersection, POI. All righty? So let's see. Program, new. All right, so where's P? Let's see. P-O-I. All righty. All right, so what do we got to do first? Okay, guys, focus. Are you ready? Your name. My name, your name. Whose name? Oh, okay. Alpha, the programmer's name, okay. All right, what's the next line? Clear home. What now? What do we do next? Prompting how many things? A, B, C, and D. But again, by the way, notice this commentary thing at the top should be longer. It should actually say what A, B, C, and D are and what we're calculating, but I don't have a lot of room here if I want to print this out, so I'm not doing that. But that's really what this comment stuff is for, to explain what you're doing. So in this case, AB is not a point, CD is not a point, like in slope, right? Remember in slope? We figured out the slope between the point AB and CD, right? Now it's the line AX plus B, the Y equals AX plus B, and the other line Y equals CX plus D. I should really put that in a comment here, but I really don't have room, so I'm not going to. So program IO prompt, and it's alpha A, comma, alpha B, comma, alpha C, comma, alpha D. Okay. And let's remind ourselves what we're doing. We're doing D minus B over A minus C is the X value, where D and B are Y-intercepts, and A and C are slopes, right? All right, so D minus B over A minus C. D minus B, right? D minus B. Okay, here we go. Quantity, D minus B. Well, it's right here. Right, D minus B. In parentheses for the numerator divided by A minus C. Alpha A minus alpha C. Close the denominator and store that as what? That's X. Okay, boom. All right, now how are we going to get Y? Right, take one of the lines, Y equals AX plus B or Y equals CX plus D, and plug in that X value. Excuse me, I'm sick. All right, so alpha A times the X plus alpha B, store that as what? And that's going to be your Y value, right? That's the X and Y coordinates of the point of intersection. So we're going to have two displays, right? Alpha Y. So let's do it. Program IO display, quote, X equals, quote, comma, X, and program IO display, quote, Y, alpha Y, second test equals, quote, comma, alpha Y. All right, so let's test this thing. Now we have some test data. If we plug in, don't test it yet, but if what we're going to do, okay, if we plug in A is 3/4, B is -3, C is what? -1, and D is 2, you should get this answer, 27ths and -6/7, right? All right, let's do that. So what is A? A is 3/4, B is -3. So let's do it. All right, so quit, program, let's see, select point of intersection, there it is. So A is 3/4, so 3 divided by 4, or 0.75 if you like. b is negative 3. That's the first line, y equals ax plus b. Don't forget the negative key is this guy. Did you get 27ths? Or the decimal version of that? And then negative 1 for C. Negative 1, the negative key, people missing. Be careful. Yesterday we had a lot of problems with people mixing up the negative sign with the subtraction sign. Don't do that. Don't doing this. So negative 1, enter, and 2. And you got, well, is that 27ths and negative 6/7? Is it? I don't know. How could you convert that to a fraction? Okay. So math, frac. Who's it going to frac? The last one? Yeah. How are you going to frac the x then? X, well, how about, okay, but I could do x and then frac it. Right? Or you could frac it probably in your program. What if you fracked it in your program? Let's see. Edit. Could we do that? Let's see. All right, let's run it again. We're plugging in this. 3/4. All right, let's run it. No. Program, execute. Okay. We're plugging in 3/4. Enter. We're plugging in negative 3. We're plugging in negative 1. And we're plugging in 2. And that's 27ths, and that's negative 6/7. So, all right, so can we frac that? I don't know. Let's see. Program, edit, POI. What if I just put a frac in here? Can I? Second, insert math 1. No, that's backwards. Wait, I got to do the x first, right? Yeah. All right, wait. Get rid of that. Put it here. Because it's like that arrow means it's inputting x into frac. Second, insert an x. Okay. And let's do that to the y. Math frac. And if it's not really a fraction, it'll just give you the decimal anyway. All right. Remember, why is it a fraction? What makes it a fraction? How do you know frac will work?
It'll show you the things.
Yeah, but when does it? When does it make a fraction? When the decimal you got is rational. What does that mean? What's a rational number? A decimal that terminates or repeats, right? Okay, if that's the case, what you get is a ratio of two integers, like negative 6/7, like positive 20/7. All right, so let's run it again. Run it. So what is it? 3/4 and negative 3 and negative 1 and 2, and there you go. The inputs are right here. 3/4 for A, negative 3 for B, negative 1 for C, 20 for D, and who didn't get the fracs? Who foobarred or fracked their code?
I got 27 to negative 6.
That's weird. I think the X is right. Whoa! You had 3/4 and negative 3/4. Well, it's a good code. D minus B over A minus C.
Oh, wait, that's supposed to be over.
Yeah, divide. Okay, go ahead. So many programs, so many times. Okay, so it was 3/4 and negative 3 and negative 1 and 2. And that's what we got, I think. Yeah, but where's your frac? Look, we added a frac here. Did I do this? Program, edit. We added frac at the end of those two lines. So that if it is a fraction, it gives you a nice exact answer. Math. Go to the end of that line.
So basically,
Yeah, both lines, that line. And then math. Enter. Do it to both lines. And so if it is a fraction, we'll give it to you. If it isn't a fraction, we'll give you this. All right, so run it like that, so you get a nice exact numbers.
What was the
3/4 and then negative 3. Yeah, just did. You just wrote code in the solve method on Sage. You know the solve command in Sage when you're solving equations? You just wrote the beginnings of the solve command. The solve command can solve any equation. Any equation. But you wrote the little bit of it that solves two linear equations. A linear equation, in other words, where two lines intersect. Can you imagine how much code goes behind the Sage solve command? That it can solve any equation, not just one of these? We solved this equation. This kind of an equation. We call that a linear equation because it's a line intersecting with a line. So we wrote that little piece of code that's in Sage in the solve command. But realize that the solve command must be thousands and thousands of lines long because it can handle any kind of equation, not just this one. Is that crazy? All right, that's just crazy talk. All right, so what are we going to do next? We're going to print stuff. I need 3 printouts. I need square, I need cube, and I need point of intersection. Remember how we print? I need square, I need cube, and I need this. All right, so how do we print? Well, wait, is there a way to actually make a file out of this? Send file to VTI? No. Is there a better way to print? Excuse me. Receive from VTI? No. Send file to VTI? No. Load state, save state, revert state, set calculator, emulation. Wait, what's an emulation? Anything interesting? No. No. I could take a screenshot. Does that work? Has anyone tried that? Screenshot? Okay, ROM wizard. About. Save her. Maybe a screenshot. All right, I'm going to do this. I'm going to get from the top with my name. All right, it's going to miss one of the displays. That's okay. All right. It's good. I want an area problem, a volume problem, and this one. So square, cube, and this. We did a bunch of area perimeter type problems, remember, right? We did a bunch of volume and surface area problems, and then we did a bunch of these. You're plugging in 4 inputs and getting 2 outputs. So square, cube, point of intersection. All right, so can I get a nice printout just from this? Take a screenshot from here. Go to clipboard. What about a BMP? What if I save a BMP file? And then what if I do clipboard? What do you get? You just get the screen? All right. This one, calculator image is better? All right, let's try that. Then what? You have to paste that into Word or something? I was wondering if there's some way to avoid the whole thing with Word. All right, where's Word? Word. I just want square, cube, point of intersection. Volume of a cube, surface area of a cube. We did that a while ago. All right, so where is Office and Word? All right, let's see. Can I paste into here? Come on. Come on, give me a blank page. Blank page. Go. Loading, really? Come on. Your name's at the top. Make sure you show that. All right, so write it now. All right, so paste. All right, so let's see, what does that look like? File, print, that. This is going to, yes, so print. Make sure it shows the first line with your name. Yo, Vicky, now that I fixed your printer, when did you print that? This is pyramid. When the heck did you print this? It just came out now. All right, who's this? This is Sam. All right, so how did you do this? You did like a full screen first? sheets, please. One for cube, one for square, one for point of intersection. Huh?
I would print more, but then it's way too cold.
You don't have cube? All right, you know what? This is getting complicated. 3 sheets of paper, guys. Sorry, 3 sheets of paper. 3 sheets of paper.
What's square? When you're done with it.
All right, you got cone, rectangle, so what's the point of intersection? All right, just give me an area problem. Like, yeah, but. Oh, there. All right, give me cone, what? Square. I need an area, I need a volume, I need a point of intersection. All right, 3 piles. An area, a volume, and a point of intersection.
All right.
Give me cone, rectangle, and give me point of intersection.
This is square.
All right, so let's make piles.
This has the first one has the volume.
Okay,
See,
this one
rectangle,
is
rectangle.
point of intersection, okay. This one's
I need to write
volume.
my name on it.
This one's square. No, your name should be in there.
Yeah. Can I just write my name on
No.
the paper?
No.
It's,
No.
we're wasting
I'm not taking Prism. I did Prism. Guys, I'm printing your work. I'm not taking Prism. I did that.
You did?
Yeah.
I wrote it too.
Yeah, we did it together. Then you did cube on your own.
All right. Well, it's not.
You can give me cube or cone.
I'll just give you going.
Okay, that's fine.
My square got deleted.
Do you have an area? Yeah, rectangle. Yeah. All right, you two, we're just printing. Hang on.
Why is printing so cube, square, and intersection?
Yeah.
Yours.
Hey, Brian.
Why won't mine?
Who's not printing? You?
Yeah,
Let me fix the printer. Sometimes the printer gets screwed up. I need a point of intersection, I need a volume, and I need an area. Right? You got it? Okay. Well, let's see what we got. This is what? Cube, so that's volume. This is square, so that's area. That's point of intersection. Okay, cool. All right, let's see where your printer went. Show the top, right? And then do number 2. I have to fix that. Okay, so we got 3 piles right here. We got area, we got volume, and we got intersect. Any print? Open a Word document. perimeter, a volume with surface area, and a point of intersection. Point of intersection, volume, area. Are we good at this? Yes. Yay.
This is square.
Square is there.
This is next square.
Okay. Intersection.
Colon.
Colon.
That's my point.
Good. All right, there you go. All right, is anyone still printing? Are we done? Square, rectangle, pyramid. I need square, pyramid, and point of intersection.
Oh my god, why isn't this working? What are you doing? What are you doing?
All righty, almost there? All right, YouTube, we're still printing. Hang on. Explain what? Why? What happened? What have you done? I don't even know. What did you do?
Why is this up?
What are you saying? Are you speaking English? Nope, it's not.
It's taking me forever to place this.
Thank God for printers. Oh God. Area, volume, point of intersection. Okay, what are we doing next? Remember the last topic in Sage, I think it was in chapter 4, we were doing lists, we were doing sums, we were doing for loops, we're doing while loops, we're doing sequences, we're doing series, right, all that stuff? Arithmetic sequence, geometric sequence, when do they converge, what's the sum? Can we write programs in BASIC like that? Like we did in Python? Can we do the same thing? That's what we're going to do next, okay? All right, so this is what I want. Remember the Westbury Music Fair problem? Remember that one? No, you don't remember that one? Remember the Westbury Music Fair has a circular stage? And it rotates, and that's not a good circle, so go away. How about, let me get a real circle. There you go. Wow, that's a weird circle, okay. All right, so let's say that's, okay, area is first, volume is second, point of intersection is third. Which one you got, point of intersection? Okay.
We need square, cubed, and point of
Square, cube, and point of intersection. All right, so remember that the seating goes like this. All right, there's like, I don't know what you call it, bleachers or something, right? Out here, a whole bunch of seats, right? And then out here, there's the same thing, and out here, there's the same thing, and out here, the same thing, right? And the first row of chairs, there's 10 chairs, and then they add a chair on each end, and then it's 12, right? And then they add a chair on each end, and then it's 14. And so forth, until you end up with 20 rows. Remember this problem? All right, what I want to do is write a program that generates a list of these numbers. Now, what kind of sequence is this? 10, 12, 14, 16? What kind of sequence is that? Arithmetic, geometric, or neither? Arithmetic. There's a common difference is what? 2. All right, so how do you write? You got the whole background over there? Okay, how do you write the general term for that sequence? I'm just talking about the sequence now, not the series. I'm not adding them up yet. It's the first term plus n minus 1 times the common ratio, right? I mean, common difference. So usually what we say is C plus n minus 1 d, why n minus 1? So that when you plug in 1, this zeroes out, and that's a sub 1, or c sub 1, or whatever it is, a sub n, is, a sub 1 is c, okay? So a sub 1 is 10. I want it so that if I plug in 1, I get 10. If I plug in 2, I get 12. Plug in 3, I get 14, right? So what is it? C is 10, and D is 2. Okay. So does that work? If I plug in 1, I get 0 times 2 is 0 plus 10 is 10. If I plug in 2, a sub 2 should be 12, right? 2 minus 1 is 1 times 2 is 2 plus 10 is 12. If I plug in, let's see, 1, 2, 3, I should get 14. 3 minus 1 is 2 times 2 is 4 plus 10 is 14. That's right. So can you write a loop that just prints them out? That's all I want. Can we do that? Well, let's try it. Here we go. Let's go to the calculator. And this is, they don't call it the Westbury Music Fair anymore, right? What do they call it? It has a new name because I think Citibank bought it or something, or their sponsor. Citibank is the sponsor of everything. Didn't they do that with the Mets? Citi Field, right? I think it's called NYCB, New York City Bank Westbury Theater. I think something like that. All right, anyway. So, let's do it. Here we go. On, quit this, program, new. Let's call this West, short for the Westbury Music Fair problem. So I'm in alpha, so W, and E, and S, and T. Okay. All right, so the idea here is we're going to use a for loop. Have we used for loops in BASIC yet? Yes. You have, but most of us haven't. That's why I'm doing this. All right. West, you know, like Westbury Music Fair. All right, so let's do alpha, quote, your name. Okay, program IO 8 for clear home. All right, so let's do a for loop. Let's see if we can just go straight to for loop. Well, actually, no, I need to input what? I wanted to print out all these numbers, but how many of them? All of them. Well, how many are there? A sub 1, A sub 2, A sub 3, up to A sub, what did we say? 20. So I have to input where to stop, 20. So let's prompt that. All right, so program IO prompt what, n to stop, just like we did. Didn't we do that in Sage? We wrote some kind of function of n, right? All right, so that will be alpha n. I'm not in alpha mode right now, right? Now a for loop. Are you ready? Hang on to your hats. Program. Do you see it? Do you see it? Number 4. Appropriately numbered 4 for a for loop. That's supposed to be funny. I don't know. All right, so now pick a dummy variable. I like to use like I or J or something. You could use X. It doesn't matter. You want to use X? All right, fine, X. X starts, do a comma, starts at 1, comma, stops at n, comma, and you count by ones. You could count by 1, you can count by a half, you can count by 2, you can count down by -1. If you say X starts at n and it stops at 1, you do a -1 down count, okay? All right, so let's just display these things. Program, IO, display that rule that we have on the board. 10 plus, parentheses, alpha n, -1, times 2. Now we can make this more general and have one of the inputs be the first term, the C, and one of the inputs be the common difference if you want, but I'm doing the Westbury problem. All right, now if that's all the loop has to do, you have to tell it where the loop stops because it's going to loop, it's going to redo this line n times, right? Unless you want more lines, but you have to tell it what's being repeated. So what I have to do is tell it where it's done. Hit enter. Go to program 7. Yeah. Yeah. All right, let's see what that does. Excuse me. Let's see what that does. All right, you got everything? The end means the end of the loop, so it knows what it's looping.
That should be X minus 1, right?
Is it X? Oh, I'm sorry, it's X. Right, you're right. That's because I ran out of space here. It automatically did that. Well, let's just do a few at a time and see if it's working. All right, so let's see. So let's run it. Program, West, enter. Now it's waiting for input. Let's say I want the first 3. Now you know what the first 3 are, right? What are they? What are the first 3 outputs? 10, 12, 14. So let's do 3 and get that. Yes? Very good. All right, run it again. How about do the 20? The last one's 48. Now, remember, you know how to add up arithmetic sequence, don't you? You know how to get an arithmetic series? Yeah, just that. Yeah, so it knows what's being looped. Because if you do program edit west, you could put more than one line in the loop that gets repeated, so it doesn't know if that's what you want. So if you just want one line, put the end right away. All right, so if you know that the first row has 10 seats, and you know that the last row has 48 seats, how do you figure out the sum in your head? N, the number of rows, times the average of the first and the last. All right, so what's the average of 10 and 48? What's the average? Well, 10 and 48, how do you average two numbers? Add them up and divide by 2. So 58 divided by 2 is 29? Okay, and 29 times 20? Well, 2 times 29 is 58, times 10 is 580. All right, so now how do I make it do that for me? How do I make it add them up? See, I don't really, see the problem is, if you put in a big N, you don't see all the output. Is there a way to put this output somewhere else? Right, so how do you put that in a list? Yeah, you can. Did you ever do stat edit in math class? You can use list 1. I think on the TI83 you're limited to 100 inputs, or 100 things in your list. You go from 0 to 999, right? Here I think you go from 0 to 99. But that's enough for what we want, 1 to 20, right? So how do we incorporate the list into our program so that it doesn't print out all this mess? I can go to stat edit and see everything right here. So I don't lose all the output, right? Because you lose the output, look at this. Where's the beginning? I don't know. And then once you have a list, can you sum it? All right, we have like 1 second left. All right, leave it there. We're going to add lists tomorrow, okay? As soon as you got a list, you can do a sum. We're going to do this with a geometric series tomorrow too. All right? right, so remember to right-click, exit, save state, or what you typed is gone tomorrow. All right, good. Bye-bye, you.